The first graph I graphed was x squared minus 3x minus 10 with the domain from -2 to 5. And so the first thing that I did is I factored that equation out to get x minus 5 and x plus 2. And that gave me the x-intercepts of that graph at -2, 0, and at 5, 0. And then that minus 10 at the end gave me the y-intercept of that graph at 0, -10. Also, the reason that at -2, 0 and at 5, 0 both of the dots are filled in is because the graph includes those points, so it includes -2 and 5 in the function. The second graph that I graphed was 5x plus 50 over x squared plus 12x plus 10. And so again, the first thing that I did is I factored that out. So I got 5 parentheses x plus 10 on the top, and then x plus 2 and x plus 10 on the bottom. And since there is an x plus 10 on both the top and the bottom, a hole is created in that graph, and I plugged that -10 into 5 over x plus 2 to get the y value of the hole. So the hole's at -10, 5/8. And after that hole was created, x plus 2 was left on the bottom, so that created a x asymptote at x is equal to -2. And then also to get 3 more points in order to create the graph, I plugged in -3 and I got -5 for the y value. I plugged in -4 and I got -2.5 for the y value, and I plugged in -5 and I got -1.67 for the y value. And since the domain is x is less than or equal to -2, I only graphed the negative part of this graph. The final graph that I graphed was the natural log of x minus 5 with the domain x is greater than 6. And so the way that I graphed that is I knew that the natural log of just x was had an x-intercept of 1, 0, and so that -5 moved the graph over 5 to the right, so the x-intercept is going to be at 6, 0, and since the domain is x is greater than 6, it only included the values that were from 6 on, and so it didn't include the negative part of that graph. So these are just the graphs that I just showed how to graph, but they're on Desmos, and they're just a little bit neater and easier to see all of the things that I was pointing out in those graphs. Okay, so the first thing is the x-intercept and the y-intercept, and then the max and the min of the graph. And so the x-intercepts of these graphs are at -2, 0, 5, 0, and both of those x-intercepts come from the graph x squared minus 3x minus 10, and then the third x-intercept is at 6, 0, and that comes from the natural log of x minus 5. And then the y-intercept is at 0, -10, and that is also found with the graph x squared minus 3x minus 10. And so there is no max of the graph because there is no point where there's an explicit max. And then the min of the graph is at 1.5, -12.25, and that x value that was found by finding the vertex of the x squared minus 3x minus 10 by taking 3 over 2 and then plugging 3 halves back into the equation to get the y value of -12.25. Next is the domain and the range of this piecewise function, and the domain is from -infinity to -10, and the reason that there's a break in this domain at -10 is because of the hole in the graph at -10, and then it goes from -10 to -2, and the reason that there's a break in the domain at -2 is because of the asymptote, and then from -2 to 5, and the reason that there is a break at from 5 to 6 is because the first graph and the third graph, there's a break, no x values exist between 5 and 6, and then the range is from -infinity to infinity because all the y values are accounted for between the 3 graphs. So increasing and decreasing looks at which part of the graphs the x values are increasing or decreasing. And so for increasing, it's increasing from 1.5 to 5, and I got that 1.5 by finding the minimum of the first graph that I graphed to 5, which is the x-intercept, and then also from 6 to infinity, because the third graph that I graphed is always increasing. And then for decreasing, it's from negative infinity to negative 10, because negative 10 is the whole, and so it's neither increasing nor decreasing. And then from negative 10 to negative 2, because negative 2 is the asymptote. And then from negative 2 to 1.5, which is again, the 1.5 is the minimum of the first graph. The next part is the positive and negative, which looks at which part of the graph has positive x values and then which part of it encompasses negative x values. And for the this piecewise function, the only time that the graph is negative is from 6 to infinity, which is that third graph, and that's the only graph that has positive x values. And then so for negative, it's from negative infinity to negative 10, which again encompasses the whole, and then from negative infinity to negative 2, which encompasses the x asymptote, and then from negative 2 to 5. So the last part of this video is on the end behavior and the limits. So the end behavior just looks at what's happening as your x values are getting closer and closer to infinity, and as your x values are getting closer and closer to negative infinity. And for this graph, as the x values are getting closer and closer to infinity, the y values are getting closer to infinity, and then as the x values are getting closer to negative infinity, the y values are getting closer to negative infinity. Limits look at an x value, and as you're getting closer to the x value, what is happening to the y value. And so the first one is asking, as you're getting closer and closer to negative 2, what is happening to the y value? And for this one, the limit does not exist, because the second and the first graph, so the second graph has a asymptote at negative 2, and so, but then the first graph ends at negative 2, and since at that point the graphs are going in two different directions, they're approaching two separate things, the limit does not exist. And then so for the second one, that one's just looking as you're getting closer to infinity, what's happening to the graph, and so the third graph is the one that you would look at for this one, and so as the x value is getting bigger, the y value is also getting bigger. And then the third one, so it's asking as you're getting closer to negative infinity, what's happening, and for that one, you look at the second graph, and the second graph is approaching 0, because the graph has a horizontal asymptote at 0. And then for the fourth one, as you're getting closer to negative 3, what's happening, and so for that one, I plugged in negative 3 into the graph x squared minus 3x minus 10, and that gave me a y value of negative 10, so as you're getting closer to negative 3, your x value, as it's getting closer to negative 3, your y value is getting closer to negative 10, and then for the fifth one, I just plugged in negative 3 into the graph 5x plus 50 over x squared plus 12x plus 20, and that gave me a y value of negative 5. So as you're getting closer to negative 3, your y value is getting closer to negative 5. And then finally for the last one, what's happening as you're getting closer and closer to negative 10 for your x value. And so what is happening is at negative 10 there is a hole, and so but limits don't, like, they still exist when a hole is there. So I knew that the hole was at negative 10, negative 5/8, so the limit of so the limit as you're getting closer to negative 10 is negative 5/8.